Okay, let's say there is two forces acting on a box. So one is in this direction and the other one is in this direction, right? So it can be two forces, something like 20 Newton or 10 Newton, right? Forces are vectors, but let's consider in general vectors. There are two vectors pointing in two different directions, right? So let's say this is the vector A and this is vector B, right? And they are making angle theta between them, right? Okay, so then what will be the resultant, right? So in the last class, we discussed if the forces are acting in the same direction, right? If the two forces are acting in the same direction, then they will adapt, no? Sorry. Now, let's say there is a box, and if the two forces acting in the same direction, then the forces will be together give the resultant, right? But if the two forces are acting in opposite direction, if the two forces are acting in opposite direction, so in this case, the resultant, now let's say this is vector P and this is vector Q, and let's say vector P is greater than vector Q. So the resultant will be in the direction of this vector, the vector P, right? With, let's say, P plus Q. So the resultant we will get, if I consider the magnitude of the vector, it will be the magnitude of P minus magnitude of Q. We can do simply get the resultant when the vectors are acting, both vectors are acting in the same direction, or either they are in opposite direction. Because they are still in parallel, we can do we can do simple calculations to find the resultant. But in this case, the vectors are pointing in two different directions. The angle between them is theta, right? So how we can find the resultant? Now here, the one important thing that we want to understand is the resultant will be anywhere between A and B, depending on their values. But if I say the resultant is somewhere here, that is totally wrong. It never going to be happen, because you are pulling this direction and someone is pulling this direction, then the overall effect will be somewhere in this direction, right? Now we will see how we can find the resultant of this, right? The system, we have two vectors and its resultant, let's say capital R. So we want to find the resultant, the resultant vector, right? So to find the resultant vector, we have two laws. One is called triangle law of vector addition, and the other one is parallelogram law of vector addition. Okay, so let's first start about triangle law of vector additions. Okay, so in triangle law of vector addition, it says if we have two vectors, now as in our example, vector A and vector B. So if we use the triangle law, I'll give you in a while the statement of triangle law, but first let me explain that. So triangle law says you take the one vector. You take one vector, so it can be B or A. I take first A vector. I take the vector here. Okay. Let's take, should be in the same directions in magnitude. Okay. So I take vector A here. Name it A vector. And then secondly, I want to take the B vector. So B vector is this. Okay. So I take the second vector and place it at the point where the first vector ends. Okay. So then I'm going to construct the third side of this, I'm going to just draw a line from starting point to ending point. So this one will give the resultant R. Okay, and keep in mind this angle is theta, and this is B, vector B. So you take one vector here, and from the ending point you take the other vector, right? So note down here the vector in same order. So it start from here to here, and then from here to here, right? If I draw this vector something like this, if I can't, I want to take this vector from the point where it is the first one ends, right? So it's here. So the third side of this triangle, right? We actually construct a triangle using these two. We take A and B as the consecutive sides of this triangle. So the third side of this triangle gives the resultant vector. So this is what we call the triangle law of vector addition. So you first write down the triangle law. So the triangle law of vector addition states that when two vectors are represented as two sides of the triangle with the order of magnitude and direction. So with the order means it has to follow this order now. Here it has an order now. It's from here to here, right? It is not something like this one, right? If I draw, it's not here, it's something like this wrong. It has to be a same order from here and then from here. So the if we do that, then the third side of the triangle represents the magnitude and the direction of the resultant vector, right? So if you want the direction of the resultant vector, so let's take alpha. So alpha is the direction of the resultant. Okay, is that clear?
Yeah.
Okay, so straight down the triangle law. So triangle law of vector addition states that, write down, triangle law of vector addition states that when two vectors are represented as two sides of the triangle, as two sides of a triangle with the order of magnitude and direction. With the order of magnitude and direction, then the third side of the triangle represents the magnitude and direction of the resultant vector. Then the third side of the triangle represents the magnitude and direction of the vector. Okay, so you can draw this. Okay, take here. Here's the vector A and here vector B. Vector E vector. And making angle theta. Okay, so that gives the from triangle of vector addition, you can write this. Okay, so if I take this as a triangle, let's say ABC triangle, A B C triangle, right? So we know how to write this vector A. I can say A vector is equals to AB vector, geometric representation, and B vector is equals to BC vector, right? Okay. Okay, so here I write R vector, which is the resultant vector, is equals to A vector plus B vector, vector addition, right? This is the vector addition. The vector addition gives the resultant. So R vector is AC vector. So here R vector is equals to AC vector. Okay. So I can write down then R vector is AC vector is equals to AB vector plus BC vector. So you can see they follow the same order from A to B and B to C. A to B, B to C gives A to C, AC vector, right? So you see the pattern, AB plus BC is equals to AC. Okay. Okay, so this is the triangle law of vector addition. Okay. And next, let's talk about the parallelogram law of vector additions. I hope you have finished writing this, so I'm going to clear it. Okay, second, we have a parallelogram law of vector additions. Okay, so here the law says, okay, if two vectors can be represented by the two adjacent sides, okay, both in magnitude and direction of a parallelogram drawn from a point, then their resultant vector is represented by the diagonal of the parallelogram drawn from the same point. Okay, so I will explain that here. Meanwhile, listening to my explanation, you can write down the law. Okay. So let us say there is this vector A and vector B making angle theta. So this is the vector A and vector B is making angle theta. And from parallelogram law, what it says, right? So here, if two vectors can be represented by the two adjacent sides of a parallelogram drawn from a point. So I consider this point, okay? From there, I want to draw the two adjacent sides. So one side is this. This is A, right? And then the second side drawn by this vector B. Okay. Okay. So let me mark. If two vectors can be represented by the two adjacent sides of a parallelogram. Okay. I think this is quite different. No? Yeah. Okay. So this is vector A and this is vector B. So okay. Then let's construct a parallelogram. Okay. Let's construct a parallelogram. Okay. Because we want if two vectors can be represented by the two adjacent side of a parallelogram. So I'm going to construct a parallelogram here. Okay, so to construct a parallelogram, I want to draw a perpendicular line to this from here, no? So I take this, okay. So this is parallel to this, I take that here at the ending point of this. And then I draw another parallel line for this one from this point. So here you can see I have constructed a parallelogram. This side is parallel to this side is parallel to this. So this is a parallelogram. Therefore, this length is equal to this length and this length is equal to this length. Okay. Okay. And then now we have constructed parallelogram. then their resultant vector is represented by the diagonal of the parallelogram drawn from the same point. So from this point, I want to draw a diagonal. Okay, so from here to here, right? So this is the then resultant. This is the resultant, you can say R vector. Okay, so this is the parallelogram law of vector addition. Now, parallelogram law of vector addition and triangle law of vector addition gives the exact same result. So that thing we can understand from here. So if I consider this, now this is vector A here, right? And I take the vector B from here. So if I draw the vector B from here, so this is vector B. So if I consider this A, B, triangle law, from the triangle law, this is the resultant. From I have here A vector, and after this B vector. So from the triangle law, I have this resultant vector, which is the diagonal of this parallelogram. So according to parallelogram law, this diagonal is the resultant of these two vectors. And if you consider this triangle, according to triangle law, this side is the resultant. So both gives the same result. Okay. Okay. So quickly draw down this. Have you finished writing? Okay, good. Okay, next let's do a small example. Okay. Okay, so let us take there are three vectors acting at an object. Okay, so 1 and 2 and 3. Okay, I'll take these two here, so I want enough space. Okay, so let's take this vector is vector A, this is vector B, and this is vector C. Okay, so the question is, here I write the question, find the resultant, find the resultant of the below system of vectors, geometrically or graphically. Okay, find the resultant of the below system of vectors geometrically. So to find the resultant, we can follow either triangle law of vector addition or parallelogram law of vector addition. So here I'm going to do in both methods. So first, let's go through the triangle law of vector addition. Okay, so triangle law of vector addition. So I'm going through the triangle law of vector addition. So I take this first vector A here. Let's take the vector A here, and I take the vector B here. So I follow the triangle law, and we know triangle law of vector addition deals with only two vectors. So until then, let's deal with A and B. Meanwhile, keeping C as it is. Okay. So I keep the C vector here, right? So let's keep that as it is here. Okay. So let us mark these vectors then. Here this is A vector, and this is B vector, and this is C vector. So from triangle law of vector addition, the resultant of A and B, the resultant of A and B will be from here to here, right? So I take, this is the resultant of A and B. Let's take that is simple R vector, right? So that means instead of A vector and B vector, I have this R vector, right? Okay. Now let's simplify this further. Okay, so what I have now here, so I have this C vector. Let's see, I take that here, and then I have this R vector instead of A and B. Instead of A and B, I have R vector because that is the resultant of A and B now. So instead of A and B, I have the R vector. So I take that here. And let's mark the vectors. This is vector C and this is vector R. Now what I'm going to do is I'm going to apply the triangle law of vector addition for these two, right? So I take one vector here, right here. So I take the first R vector, take down here, and then the vector C, which is this, from here. Let us see, these two are equal. Yeah. Okay. So then the resultant of these two. Now let me first mark, this is C vector and this is R vector. So I'm applying the triangle of vector addition for this. So what I have here, the resultant. Instead of R and C, I have this resultant vector, which is I denote as capital R. So this capital R is the resultant of this vector system. Okay. So now the next, I'm going to follow the I'm going to follow the parallelogram law of vector additions. Okay. Okay. So first I have A vector and B vector. So let me draw A. Let's make it quick. Okay. So let's take the vector A here, and then the B vector A here and B here, and C will be here. Okay, and then let's follow the parallelogram of law of vector addition B, C. So all I want to do is draw, complete the parallelogram. So here's a line. I take that here, and then another line from here, a parallel line to with this side from here. So I constructed the parallelogram. So according to parallelogram law of vector addition, the resultant will be from here to here. So I take that is simple R, right? That is very clear. No? So here A and B, we have R. So if I take this A, and this is a, if I draw a vector here, this vector, let's say something like M, right? So M vector is equals to B vector, no? The equality of two vectors, we talk about that in earlier, right? They are same type, and they are, because if they are same type only, we can add, so they must be same type, and then they are in parallel, and also they are acting in the same direction. So this vector is equal to B vector. So A and B, so we have R. So A, B, we have R, right? Good. Now, the next step, let me draw here, maybe here. So what I have instead of A and B, I have this R vector. I have the R vector instead of A and B. Let's take this. Okay, and then I take that. So instead of A and B, I have the R vector here. Okay. I think I don't have enough space there. I take here. Okay. And then I have this C vector here. B, yeah. Okay. So now I'm going to apply the parallelogram law of vector addition for this R and C vector. So let me draw a parallel line. So take this from this point and take this from here. Okay. So the resultant of this will be then resultant of R and C is the diagonal joining from here to the diagonal from here to here in this parallelogram, right? Okay, so I mark that as capital R, which is the resultant of this one, this system. Now, if I did correct, this R and this R and this R should coincide. Yeah, exactly. You see? So I have done this very well. So you see these two coincides, no? The length and the direction, perfect. Okay. So my geometric construction is so good. Okay. So you see, so this is getting the same answer in the same two different ways. And now here, I'm going to do another method to find this R. Okay, so I'm going to do that here. Okay, I take this vector system and I'm going to do this. Look carefully. Okay, let's take, okay, some from, I draw the A vector. Let's make it small. Okay, A vector, and this B, and this is C. Okay, so first I take the A vector. Come here. Okay, and second I take the B vector. Okay, good. And third I take the C vector from here. And then what I'm going to do is I'm going to draw a line joining from here to here. Okay, so first let's mark this. This is the vector vector A, this is vector B, this is vector C. So I say this is the result. If this is the result, and then this and this should coincide, right? Little bit deviated, but it's correct. Okay. Okay. So this method of finding the resultant is called Polygon law of vector addition. Okay, is everything clear in this picture? Let me know in the chat box. Good, great. Okay, so then our next topic will be polygon law of vector additions. I hope you have finished writing this, and I have give you a minute of time. If you have already finished, let me know in the chat box. Once you finish writing this, yeah, okay, done, good. Okay, so let me clear all the drawings and let's go to our next topic, polygon law of vector additions. Okay, so write down the topic, polygon law of vector addition. Yeah. Okay, so polygon law of vector addition states that if a number of vectors can be represented in magnitude and direction by the sides of a polygon taken in the same order, then their resultant is represented in magnitude and direction by the closing side of the polygon taken in the opposite order. So first write down this statement or the law. Once you finish writing that, let me know. So I'll start to explain what it means. Okay. Okay. Let me know in the chat once you finish writing. Okay. So then, okay, fine, perfect. Okay, so let's now explain this. Let's say I have a system of vectors. Okay, so take here we have a system of vectors. So okay, so let's say we have n number of vectors. Okay, so I say this is the vector A, this is vector B, and this is vector C, and this is vector D, and vector E. And I don't know, there are so many numbers, and finally n number of, right? N number of, so n can be something like 1 or sorry, something like 10 or 25, 13 or 102, any value, right? We have a system of large number of vectors. Okay, so now I'm going to follow the polygon law of vector addition, right? So yeah, let me first take all this, copy that. Okay, so the Polygon law of vector addition says if a number of vectors can be represented in magnitude and direction by the sides of a polygon taken in the same order, So I take this A vector here first, okay, and I have the next B vector. Okay. First I say there are some in number of vectors dot dot dot. Let's put some dot dot dot. I don't know, there are some in number of vectors. Okay. Okay. So I take vector A, vector B, and then I have to construct a polygon taken in the same magnitude, represented by the magnitude. That means this length of the polygon should be equals to the, because we know the magnitude is proportional to the length. So we take in the order of magnitude and direction. So A is pointing this direction, so that direction, like that, and then we want to follow this method up to the nth vector, right? So I take that and D, right? And let's say there are other vectors. So let's mark vector A, vector B, vector C, vector D, and I don't know other vectors are there. Dot, dot, dot. And finally, I draw the vector N, right? So I draw the vector N, which let's say it's somewhere down here. Okay. Okay. So in the same order, then the resultant is represented in magnitude and direction by the closing side of the polygon. Okay, taken in the opposite order. So they all in this order, right? Following this order. So the resultant is in the opposite order from here to here, closing side, but in the opposite order, right? Okay, so that is the resultant R. I have marked the vector N there. So this is the N vector. Okay. Okay, now this is nothing but the same triangle law. Actually, this is we're using triangle law many times here to obtain this. Now I can show you that. Okay, so we're actually using triangle law many times. Now instead of A and B, we have this vector, right? Okay, instead of A and B, we have this vector. Now we have this vector C, D, blah, 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 up to N. Right now, A and B is cancelled. Now instead of A and C, we can use this vector. Right. So here these A, B, C are not there. So only this one and D, blah, blah, blah. And then I put this one, right? So we now instead of this A, B, and C, I have this vector, and this and D gives from triangle law, I get this vector. So you put bunch of triangle laws to get actually polygon law of vector addition, right? Did you understand what I said just now? I mean, how to obtain the polygon law from triangle law of vector addition? Did you understand that part? Okay, great. Okay, so you just draw this and note down this. Okay, draw this. So we have applied the triangle, this one. Okay, you already done. Very good. Okay, so that is the polygon law of vector addition. Now here I'm going to do one small explanation. Now when we drawing this polygon law of vector addition, suppose let's say the nth vector. Let me first erase this. Okay, that's not that one. This one. Okay. Suppose if the nth vector is, when we construct this polygon, the nth vector, the ending point is coincide with the starting point, right? So what can you tell about the resultant in this case? What is the resultant? What can you tell about the resultant in this case? Any idea? What would be the resultant in this case? Just think. Now, resultant is the vector drawn from starting point to ending point. So starting point and ending point is coincide, right? So what is the length of that? If we draw the length of that side, it's 0, no? So what can you tell about the resultant vector? Okay, so in this case, when now just consider the polygon law of vector addition. Okay, when we construct this polygon law, the resultant is the vector drawn from the closing vector, right? Right, hold on. Yes, so this is the nth vector. So when we draw these vectors, we can see that the ending point and starting point coincide, right? So suppose, come on here, this is, suppose if this is this, right? The resultant vector is the drawn from here to here, no, right? Here to here. So it has some value. It has a value, length, and it has a direction, right? Now, again, what if it is something like end up somewhere here? Now, in this case, the resultant vector is larger, right? The resultant vector is larger, and sorry, come on, get the arrow. Yeah. So the resultant vector is larger than that. It has a length, magnitude, and direction. Now, if there is if last vector, nth vector is coincide here, so the length will be 0, no? The length drawn from starting point to ending point is 0, no? Okay, did you understand that? Did you understand that fact? Okay, good. So then R vector, we say then it is equals to, we can't say 0 because vector cannot be equal to a scalar. 0 is just a number, no? Right? If I write this, if I write something like this, it is totally wrong. Mathematically, fundamentally, it's wrong. So the resultant vector, we say that it is a 0 vector. So 0 vector. Okay. So we usually vector A, we can also write like this A vector. You might have seen some textbook, you see like this vector A. Right? So null vector, we usually denote as 0 vector, we usually denote as rather than putting arrow on the top. It's not wrong, but mostly we write like this. Okay. So in that case, the resultant is 0 vector, null vector, because there is no resultant. The system is, if there are forces, right? Let's say if there are forces acting on an object, so the resultant is 0, means that object is in balance. No external force, no unbalanced force is applied on that object. You understand? Did you understand that? Okay, good. So let's put a small note about a null vector. So I'll clear this page. So we are done with here. Okay. Okay, anyway, you copy this again. And suppose, let's say it is like this, then the resultant is 0. Okay. The resultant vector is the null vector. Okay. The resultant vector is equal to 0 vector or null vector. Okay. You just copy this and write down this. Are you done? Okay, good. So let's put a small note on null vector. Write down small topic null vector. Okay. A vector whose magnitude is 0. A vector whose magnitude is 0. And I still did not finish this sentence. Okay. So vector whose magnitude is 0. So null vector I take, and its magnitude is equal to 0. 0 is our normal number, usual number, right? This is a vector. This is vector whose magnitude is 0, right? So this one is 0, this number 0, 1, 2, 3, that's 0. Okay. Okay. Now, vector in the sense, we know vector is something who has both magnitude and direction. So magnitude is equal to 0. So what about the direction? Any idea? What about the direction of the null vector? What do you mean same? Same direction of what? Okay, suppose if I say no direction, is that true or false? Null vector have no direction. Is that statement true or false? False. Very good. Because vector must have a direction, right? So a vector whose magnitude is 0 and direction is any arbitrary direction. It can be any direction. Okay. Okay. So write down this fact and then write down note on this. Okay. Okay, and okay, so write on the topic arithmetical determination of the magnitude and the direction of the resultant vector. Arithmetical determination of the magnitude and the direction of the resultant vector. Okay, let's start from the easiest case and let's increase the complexity. So easiest case is when two vectors are acting in the same direction. So we have done this already, right? Okay, so let's say this is vector P, this is vector Q. So the resultant vector will be in the same direction. Magnitude is equals to P plus Q. I draw this. Wait, hold on. Let's take this something like this. Okay. Okay. So the resultant, we know R is. So the resultant is the addition of two vectors. R vector is equals to P vector plus Q vector. This is vector addition. And the arithmetical determination, that is the value R equals P plus Q, and the direction, now here P is, now I write down here the fact R equals the magnitude of R vector and P equals to the magnitude of P vector. And Q equals to magnitude of Q vector, right? That means how big it is. Okay, so here R is equals P plus Q. Right. So this little bit. Okay. So P plus Q equals R. Okay, so that is the easiest case. And the second scenario, let's take again a box. Okay. Now P vector is acting this direction, let's say, and Q vector is acting this direction. Okay. So this is vector P, this is vector Q. So the resultant vector here in this case, we know, so resultant is always R equals P vector plus Q vector. So now let's write the arithmetical determination. Just finding the value of the resultant. So okay, so here is the resultant. Okay. So R R vector, here R vector. So here R equals P minus Q. P is large, therefore P minus Q, right? So it's something like this. You take this P vector and you take that, subtract the Q vector. That is, you can think of the triangle law. Right? So triangle law, but in the triangle law, if now we know triangle law means we have to take the other vector from I think I cannot change the direction. This why it is. Yeah, not possible. Okay. Okay, so let's take this Q vector, right? So P minus Q is equals to R. Okay. Okay. And next case, complexity is a little bit larger. So here now we have, let's say, box. And the two vectors acting, one is acting this direction and the other one is acting this direction, right? Okay, so now we want to find the resultant of this. To find the resultant of this, what I'm going to do is I'm going to follow the triangle law of vector addition. Okay, let's follow the triangle law of vector addition. Here I have marked their forces. So is the P vector. This is the vector P, and this is the vector Q. Right now, I'm going to follow the triangle law of vector addition. So let's take P and Q here. Okay, so I take one vector here. And take the next vector P, Q here. So from triangle law of vector addition, the resultant will be the line joining from here to here.